we're going to be discussing in great detail, I'm afraid, the subclasses and the different groups of mammals. So to dial you in kind of taxonomically here, we're in the class Mammalia, and we're going to be going over some of the subclasses, the infraclasses even, and some of the orders of mammals here. So if we could jump on in here, we're going to start with the subclass Prototheria. And Prototherians arose in the Cretaceous, and they're still around today. And some examples, just so you can kind of start thinking about what these look like, are your platypus and your spiny anteater. These are also referred to as monotremes, so another term there for you to remember. And these are early mammals, but generally thought of as kind of reptilian in nature, which is kind of interesting. And if you know anything about a platypus, which maybe not many of us do, they do lay eggs actually. And so that's kind of a connection to reptiles that we're making here with these monotremes. So platypi, is that a word? Platypuses, they are found, and the spiny anteaters, they're found only in Australia and New Guinea actually. So if you haven't run across one of these, don't be surprised unless you live in unless you're lucky enough to live in one of those areas here. The next subclass that I'd like to get into some detail here is the subclass Allotheria here. Those arose in the mid-Jurassic and they went extinct in the Oligocene. The order that we want to kind of dial into here is the order Multituberculata. Try saying that 3 times fast there. Multituberculata. And those are the largest mammal group of the Mesozoic, and they're consisting of rodent-like omnivores actually here. So we're in the subclass Allotheria and the order Multituberculata. There, I've said it 3 times. All right, and what that term actually refers to is the structure of the molars of this group of rodent-like omnivores. And basically what you have is kind of a longitudinal series of these really sharp cusps actually. And so that's called multi, so many, and then tuberculata kind of refers to that cusp-like shape on those molars of these Allotherians. The next subclass of the class Mammalia is the subclass Theria, and these are your beasts. Within this subclass Theria, we're going to dial in a little bit closer here in the Metatherians, which arose in the Cretaceous, and they're still alive today. And these are your marsupials. So marsupials is an organism that basically the offspring are born dependent on the mother, and they're sort of housed in a pouch until further development, basically. So some examples of marsupials I'm sure you're coming up with already are the kangaroos, opossums, Tasmanian devils, and koalas. So again, this group is confined mainly to Australia, South America, but the possums range to North America actually. And I'm laughing because definitely seen a few of those on our roadsides here. I have a co-host here today. We have a little chinchilla here with us. He's going to keep you entertained while I lecture at you. All right, so what we're talking about here is we're in the class Mammalia, and we're dialing into the infraclass Eutheria here. So we're referring to our placental mammals actually. Oh, that's cute. All right, so we want to dial in here. The infraclass Eutheria arose in the Cretaceous period, and obviously we still have modern day representatives here. Ooh. All right, so, but what I want to note is that not all Eutherians are actually placental mammals. So the extinct Eutherians actually were not placental mammals, but all the modern day Eutherians are placental. So what that means is that they have a specialized placenta that supplies the fetus with oxygen, and it removes waste, and it masks the fetus from the mother's immune system actually, to kind of keep it safe during the gestation period there. And the placenta allows for a longer gestation period. And the Eutherian, whoa, he's out of here. The placental mammals actually do include several orders, and that's why we have this little representative rodent here today, is so that we can go through those orders in detail. Within the infraclass Eutheria, we have several orders here. So again, we're kind of marching down taxonomically. So now we're down to the order level. So the first order is Insectivora. And it's named that because of their diet. They eat insects, actually. So Insectivora, they arose in the Cretaceous, and they still persist. These are your primitive placental mammals, actually. And unfortunately, they have smaller, well, not really unfortunately, they have smaller brain cases here. So that's kind of the distinguishing feature of the order Insectivora. A couple examples that you could think of are shrews, moles, and hedgehogs. The next order is the order Chiroptera, which we've discussed in the adaptations to flight, or the development of flight discussion there. And these are your bats. So they arose in the Eocene and obviously still persist in the recent, if you've been able to observe these in the wild at all. And these are the only mammals that are capable of flight. All right, so another order of the class Mammalia here is the order Rodentia. And here's our, oh, he's switching my slides here on my computer. All right, is the order Rodentia. So here we have a gorgeous and speedy representative of the order Rodentia. So this is a little chinchilla here. Oops, try to keep him corralled. Oh man, he's adorable. All right, so the order Rodentia arose in the Eocene, and obviously they're still around today in the recent. It's about to spring off here, our little table. And they have one pair of incisors per jaw, so on the upper and lower, on the upper and lower. And they're usually, those incisors are usually exaggerated, so you want to keep that in mind when you're dealing with these guys. Some other examples other than chinchillas are rats. Come on back to the area. Here we go. Are rats, mice, beavers, and woodchucks, and chinchillas. Another order in the class Mammalia is the Lagomorpha here. And so we have some gorgeous examples here, rabbits, and I think they're going to cooperate with us for their description here. So Lagomorpha arose in the Eocene, and obviously they're still around today, so we say the Eocene to the recent. And something that distinguishes Lagomorpha from other rodents actually is that they have two pairs of incisors on the front of their jaw there, on their upper jaw actually. And so we have a couple examples here. Couple of gorgeous rabbits in the order Lagomorpha, and we're in the infraclass Eutheria here, taxonomically, if we want to dial in there. So I'm going to leave these guys here since they're behaving, and we'll move on to a couple of descriptions of orders that we don't have examples with us in the studio here, but you'll see why in just a minute. All right, so the order Artiodactyla is next that I want to describe here, and they arose in the Paleocene, and they're still around today, and these are even-toed ungulates. So it's a description of their hooves actually, and so they either have 2 or 4 branches on their hooves. So these are even-toed ungulates. And examples of these are cows, deer, pigs, camels, sheep, and hippos. Just keep in mind that artiodactyls are your even-toed ungulates. We got cow, deer, pigs, and camels, which we couldn't fit in here. The next order is Perissodactyla, and so you can kind of tell by the naming there that it's similar to Artiodactyla, except these guys are odd-toed ungulates. So they either have one part of their hoof or it's divided into 3 actually. And so Perissodactyla arose in the late Paleocene, and examples of these are horses and rhinos. So again, we'll give you something to look at here, but because we couldn't fit our horses and rhinos into our studio here. Another group of eutherians is the order Cetacea, and this group is definitely unique because these are mammals that have transitioned into the marine environment. So how you can identify a cetacean is that they have a fusiform body shape. So if you know football, it's shaped like an American football actually. And so it's kind of pointed at the front, it gets wider sort of in the mid region of the body, and then it comes back to a pointed shape in the back of the body there. So a fusiform shaped body, that's distinct here. They do have forelimbs that evolved into flippers, and they do have vestigial hind limbs, meaning they still have hind limbs, but they're not useful to the organism really. And one more thing to note about the cetaceans that will allow you to identify these organisms in the marine environment in comparison to a fish or maybe a chondrichthyes, a shark maybe, is that their tail has horizontal flukes. So the tail's kind of divided into 2 parts, and it's in the horizontal orientation as opposed to the vertical orientation of the flukes of a shark, for example. And the actual organisms that belong in this group are your whales and dolphins. Another order in the infraclass Eutheria, our placental mammals, is the order Carnivora. And remember, the distinguishing skeletal feature that identifies a carnivore, or this order Carnivora, is the presence of the carnassial complex. So again, we're referring to our last upper premolar and the first lower molar. And remember, the carnassial complex is just that those are situated, so the occlusion of those teeth, how they meet, is actually more of a shearing motion than actually kind of chomping together there. So they shear past each other and they can cut meat. So this is aptly named the order Carnivora. So carnivores, or this order in particular, arose in the Paleocene, to the recent. And some families that I'd like to identify, kind of run through some of the names here of these different families that are in the order Carnivora. We'll start with the Felidae or the Felidae. These are your cats. And something that you would note about this family is that they're the most specialized carnivores. So if you take a look in a cat's mouth, it's all sharp teeth. They don't even really bother with anything blunt. Everything is definitely ready to cut meat. So these are highly specialized carnivores here. The next family is Canidae, and these are your dogs or your canines. Another family is the Mustelidae, and these are your weasels, ferrets, badgers, and wolverines. And again, that group definitely looks kind of like the order Rodentia, but if you take a look in their mouth, that's where the distinction comes here. Here I have some co-hosts here to help me explain this group, are the carnivores. So I have two ferrets here, and they belong in the order Carnivora. Arr, arr. Oh, it's meat. It tastes delicious. Whoa, and there we go, an example of the canines of the order Carnivora there. Another family in the order Carnivora is the Ursidae. Are they all right? I feel terrible. Okay, another family in the order Carnivora is Ursidae, and those are your bears. And the last one is Procyonidae. Oh, is your raccoons, which he kind of looks like with his mask, I suppose. But that's the last group of families in the order Carnivora. So we've given you a lot of information about the different groups in the class Mammalia. And remember, there's several skeletal features here that are distinguishing the class Mammalia from other classes of organisms. And then we've gone in detail into the taxonomical groups, when they arose, and the details that distinguish these groups of mammals.